very pleased and honored to introduce Myrna Wooders. Very quickly, because she hardly deserves some introduction. Myrna is a professor at Vanderbilt University and also an associate, I think, at New York, Abu Dhabi, right? And we owe Myrna a lot of things. And before I speak about research, we live with Myrna almost all along the years because she has provided the profession, the world profession, a number of institutional tools, such as Economics Bulletin. She's the founder of this journal, and also the Journal of Public Economic Theory. She's the founder of the journal, and I think she's still the chief editor of this journal. And of course, she's also the president of the Association for Public Economic Theory. Thanks, Myrna, for that. That is very important for everybody, not only for the few people who are just working on public economics, but the whole community of economists, I would say. And now switching to research, of course, Myrna has an impressive record of publication in a number of in very prestigious journals, such as Econometrica, Journal of Economic Theory, Games and Economic Behavior, Journal of Mathematical Economics, Economic Theory. Let me stop here. That's too long. And she focuses mainly on her research on game theory, I would say, my personal view, with some important application in a number of important concepts and tools for economics, such as, of course, public goods, network, coalition, T-boot model, of course, maybe in the early day of your career. I don't know if you are still working on T-boot model. And more recently on experimental economics as well, and new topics maybe in your scientific research agenda, such as discrimination and maybe genetic information. No? Okay. So I'm going to stop here because that will be too long. Thanks, Myrna, for accepting this invitation. And the floor is yours, basically, if you want to join me. I don't know if this is okay, or shall we switch to this one? I don't know. What do you think? Is it okay? Looks good.
Okay, thank you. Okay.
I forgot to say something. For remote participants, if you have some question, you will have to ask your question via the Zoom link, the chat on Zoom, the Zoom application. Okay, and I will try to redirect your question to Myrna. Thanks, Myrna.
Okay, good morning. First, thank you for that introduction. That was very kind. It's been a great part of my career to do things like edit the Journal of Public Economic Theory. And in principle, I'm the chief editor, but Rabah here is doing most of the work. Okay, so Rabah Amir. Yes, in fact, I hope to become a figurehead. That's my aim in life. I want to, with the journal, to become a figurehead. And also, I wanted to say that I'm very honored to be here giving this keynote lecture for this conference. I know it's a very important conference, particularly here in France. And I think, in fact, I think France is generally very important for public economics, right? We publish a fair number of papers by French authors, and we are grateful for that. We're grateful for your support. As Charles indicated, right, I'm turning basically to discrimination now as one of my main lines of work. I've been interested in discrimination for quite some time. In fact, since I was a kid, you know, we grew up in a small town in Alberta. We were the kind of the poorest. We were the poorest family. My dad preferred working other people's machinery rather than working on his own and getting on with our farming. And one of the really kind of amazing experiences, I want to tell you this, right? My uncle drove the school bus when the school bus, before the school district was consolidated. It kept him in cigarettes, Okay, just that's about how much it paid. And then this, it was for years, right? And in the winter, it's actually a van with a heater and horse-drawn, because, you know, this is rural Alberta, right? And that was a few decades ago, to say the least, right? And then the school district became consolidated. Driving the school bus, a big yellow school bus, became a job, and it went to the piano teacher's good-for-nothing husband. Okay, so, right, you know, I've sort of always wondered about discrimination, but discrimination is it's difficult to study, right? It's difficult to study. Most of the work on discrimination looks at discrimination that people bring into the lab. Okay, I'll tell you about one of the most striking experiments I know of. And this was by Ernesto Rubin and some of his co-authors. Okay. And they had a bunch of students, male and female, do some math problems, like adding up four numbers, each of 4 digits. Okay. And then, ooh, okay. Then they had the students sort of evaluate other people. That people would come on the stage, right? And they would then decide whether they wanted to make them job offers. And twice as many men as women got job offers, right? Twice as many. And in the math scores, there was no difference. There was no difference, right? But the point I want to emphasize about this is that people had brought those attitudes that gave these results into the lab. They brought them into the lab. It didn't sort of look about why they brought them into the lab, right? What was the basis for this, right? How come people behave this way? How come they hired the good-for-nothing piano teacher's husband, right, to drive the school bus? You know, so we want to get really at the foundations of discrimination, sort of how does it arise? Why does it arise? And we focus in on own experience, right? And own experience, and this is our second paper on the topic. And I have to say that I want to mention Edward Cartwright. A number of years ago, Edward Cartwright, nearly 20 now, was my student at the University of Warwick. And we did some pretty highbrow game theory, but his real interest was actually, I think, in behavior, right? So I have to thank him very much, because he's developed the tools and the knowledge of the literature on experiments that I can take advantage of, right? As you may know, my work in the past has tended to be heavy theoretical, but I got to say that the experiments we do kind of have some generate actually interesting questions, theoretical questions. Okay, so please feel free to interrupt if you have any questions. I think you have to write questions to you, right? They write them. Pardon? You can just ask. Oh, you can just ask. Good. And there's supposed to be people with microphones. Yeah. Are there people with microphones? I don't see any microphones except mine. There should be a few microphones at the bottom of the. Pardon? There should be a few microphones wandering around. Ah, okay. They have 2 microphones. Good. Okay, good. Because this is a large room. Okay. So what Edward and I do is we create discrimination in the lab, right? We don't measure this discrimination people bring into the lab. We create it, right? And it's kind of amazing. In 10 experiences, people can become discriminatory. We published our first paper in JIBO very recently. Okay. So I want to tell you a little bit about that paper first, because that's very foundational to what we're doing. So in that paper, subjects are assigned two types, either effort matters or luck matters. And the subjects don't know what type they are, you know? Maybe I've just published a lot of papers because I'm a pretty girl. I've never really thought that, but you know, it's a possibility. Okay, maybe. Okay. So anyway, they're assigned these types. They don't know what they are. And then they have to make a series of decisions with probabilistic rewards. If you're a luck matters person, well, I'll start here with your effort matters person, the probability of a reward is an increasing function of your investment. You get an endowment and you can invest. The function goes from 0.18 is the probability of getting a reward if you're an effort matters, and then with no effort or minimal effort, and it goes to 0.84 if you put in maximal effort, right? That's the probability of getting a reward. For the other type, the probability of a reward is independent of investment. Subjects do not know their type, okay? But we do this 20 times in the experiment. So it seems that by the 10th time, most subjects can be pretty sure about what their type is, okay, if they update. I did this with an honors class at Vanderbilt, and you know, they got out their pencils and updated right away and figured out their types very quickly. Do they know their types? Yes, they know there are two types, right? They know the entire game, or they know the entire decision problem, right? Then, right, in the second part of the experiment, I think I haven't put the second part of the experiment here, right? Yeah, in the second part of our first experiment, people had to estimate, each subject saw 10 CVs. What is a CV? It's a bonus record. The bonus record of the last 10 decisions, right? And whether you got the bonus. So you just see the bonuses and you don't see the effort, but then you have to estimate the effort. Okay. And what happens? Those people for whom effort pays, those people who had to work for rewards, i.e. input effort or invest, were quite able to judge or estimate the effort put in by everybody. Their estimates or evaluations of other people's efforts based on their rewards were quite good. Whereas those people for whom luck matters underestimated the rewards of everybody. One aspect I want to emphasize is that we did 20 runs of the experiment. In the first 10 runs, we started analyzing the data from the 10th experiment on, because by that time people should have known what their types and had some understanding of the experiment. Okay. Yes. So this is where the discrimination comes in, right? Those people for whom luck matters are less able to evaluate the work of the effort of others. That's kind of our conclusion. But in that experiment, types were exogenously assigned. They were randomly assigned by a computer to people. But in the real world, right? In the real world, we learn through interaction. Okay, we learn through interaction. So let me describe now the current paper. So we have a two-stage game between a worker and an employer, Bob and employer Alice. Each player is assigned the role of either employer or worker. Workers and employers are randomly matched in pairs. So now, whether effort or luck matters depends both on the worker investing and the employer, giving bonuses, right? So this is really a gift exchange game. You know, the employer or the worker makes a gift of some effort or investment, and then the employer decides whether or not to make a gift back. Okay, it's a kind of standard sort of game. So the major concern of the worker, of course, is will the employer reward effort? And you know, I mean, scientific presentations are not like mystery novels. So I can tell you the conclusions first. workers who were rewarded for effort estimate the effort of others quite closely, while those who were not rewarded for their effort underestimate. Yes, again, we get the same sort of results. It's a more difficult situation, of course, but what it shows is that with 10 experiences, you have people who are behaving differently in the sense that those for whom luck matters don't appreciate the effort of others. Okay. You don't want a chairperson who says that, well, so-and-so published a paper because he's lucky. Okay. Maybe that happens, I don't know, but I think probably effort makes a lot of difference. Oops, what's happening here? So here's the experiment, or the theoretical model, pardon. Alice employs Bob for T periods. Bob chooses effort from a set, which has a compact set, minimum and maximum. Then Alice observes Bob's choice and chooses whether to give him a bonus. Okay, and Bob's payoff here is a constant plus a bonus, whether or not he gets a bonus. So if he gets a bonus, his payoff here is R. If he doesn't, it's 0 minus the effort he puts in. And then Alice's payoff is, again, a constant plus something that, a multiple of the effort, right? So, and then the cost of the bonus, if she gives a bonus, right? So this would be either 0 or 1. And this, of course, depends on the worker's effort. Is the model clear? Any questions? Okay. And we make an assumption here. We make an assumption to ensure that it's worthwhile to work, right? That the payoff to working is productive, okay? And the bonus is such that if he exerts maximal effort and Alice pays a bonus, right? Yeah. That Alice does better if Bob exerts maximal effort and she pays the bonus than if he exerts minimal effort and she does not pay the bonus. Okay, this is just the parameter values, right? It's just a reasonable game, the kind of game you would expect. And the total payoffs over the periods are just the undiscounted sum of payoffs over the T periods. Whoops, sorry. Not surprisingly, the Pareto frontier is characterized by outcomes in which Bob chooses maximum, Yes, the Pareto frontier is one where he chooses maximal effort, and the unique subgame perfect outcome is where he chooses minimal effort. When I teach game theory, incidentally, I always tell my students, you want to learn game theory and then you want to learn how to try and change the game often. You don't necessarily want to play the equilibrium, right? And of course, in this game, that's not what you want to do if you're Bob. You want to try, right? You want to try and get a reward. Maybe Alice will reward you. So we use the same experimental parameters as we did in our 2020 paper. And an important thing is the closest they can get to equal payoffs, because equal payoffs are kind of something that people think about. I mean, nobody wants to be screwed and give the other person more than they're getting. Okay. And here is the experimental parameters, or the information about the experimental parameters. I thought it might be useful for you to see that. If he puts in minimal effort, then both of them get in total 153. And the bonuses, incidentally, were 50 in the experiment. 50, I think it was 50 pence. Okay, if he puts in maximal effort, they get the maximal payoff that they can achieve. And this is if This is if Alice doesn't get the bonus, right? Then Bob only gets 47 and Alice gets 170. And this is if Alice gives the bonus, then Bob gets 97 and Alice gets 150. Okay. So you see, sorry. So we're going to consider basically tit for tat equilibrium. So Bob plays tit for tat, more or less, right? And Alice also more or less. We'll see what the more or less is. So this E hat here is the level of effort above which the gains to Alice from Bob's effort are sufficient to pay a bonus to Bob. So as long as Bob puts in effort greater or equal to E hat, then Alice has an incentive to give him the bonus, right? It's worthwhile for her. We want to assume, again, some parameter values so this game has the reasonable properties we would expect. And for our experimental parameters, E hat is equal to 28. So at that level, it's worthwhile for for Alice to give a bonus. Oh, that's, I somehow missed a whole bunch of pages here. I don't know how I did that. Oh, I know, I'm going the wrong way. So how am I doing on time? Okay. Yeah, so basically we're going to play tit for tat. Here's where we are. Right. So we define high effort as enough effort to get to make it worthwhile for Alice to get a reward, give a reward. And Alice uses a tit for tat strategy if she gives a bonus if and only if Bob exerts high effort. That's the first sort of description of this. Okay. Alice can be one of two types, however. With probability delta, she plays tit for tat, but with probability 1 minus delta, she is payoff maximizing, right? So if she's payoff maximizing, she employs a strategy that maximizes her expected payoff conditional on delta being common knowledge. So a tit for tat equilibrium, right? Oh, I should point out here, just in case, okay, somebody's not thought much about tit for tat. In this case, and the way the parameters are set up, it's worthwhile for a payoff maximizing Alice to give a bonus, except a tit for tat or Bob. It's worthwhile for Alice to give a bonus in every period except the last. Okay, but life is not that simple. Okay, and this is the equilibrium then, right? Bob maximizes payoff given the behavior of Alice and common knowledge of delta, the probability with which she is a tit for tatter, and a payoff maximizing. Yeah. Sorry for this kind of confusion. Oops, here. What happens here? Okay. Sometimes you see I go down when I want to go up. Yeah. 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 One of the interesting things, and it's just a little side note here, is in our experiments, about half the Alices do pay a bonus in the last period. Okay, so half of them seem to be real tit for tatters. So a key result is that if the probability of Alice being tit for tat is sufficiently high, it is consistent with tit for tat equilibrium for Bob to exert high effort. So here is a theorem. I'm thinking right? If the belief that Alice is a tit for tatter is sufficiently large, then it's worth, then Bob will believe that Alice will act as a tit for tatter with sufficiently high probability so that he should put in effort, right? He should put in effort if he believes that she's a tit for tatter. Okay. And the way this is stated is why the L is in there, because he could, for 10 periods, he could just sort of learn, right? And then after that, he should know pretty well the behavior of Alice and what he should be doing. Okay, so that's why the L. This tit for tat equilibrium could start at any point in the game. For our experimental parameters, a sufficient condition for Bob to have this belief that Alice, or a sufficiently strong belief that Alice is a tit for tatter. For him to be a tit for tatter is delta is greater than 0.22. I didn't quite hear you. There's a microphone there. Rob is speaking. Pardon?
Does Alice know her own type? This is a Bayesian game.
Oh, yes. Alice knows her own type.
Okay.
But Bob doesn't.
Bob
Right.
knows that. Okay. Thanks.
Thank you for that question. Right. So if a certain parametric conditions are satisfied, there exists an equilibrium, a tit for tat equilibrium, where Bob exerts sufficiently high effort in each period. Okay, but it really depends on Bob's belief, right? And the probability that Alice is a tit for tatter, and whether Bob has a sufficiently high belief that she is a tit for tatter, right? She doesn't have to be perfectly tit for tat. She may make errors, she may tremble. But even if Bob has got a reward for 8 periods in a row and then Alice doesn't give him a reward, what should he do? Well, should he not work in the 9th period, or should he? Okay, well, he should, if he believes that really it was a mistake, right? That she's going to, continue giving him rewards. Now, of course, Alice, who's a payoff, if she's a payoff maximizer, knows that Bob knows that Alice might tremble. So a payoff maximizer would want to give the bonus just enough times to keep Bob on the, right to his minimum belief, right? Yeah, whereas a tit for tatter, real tit for tatter just may make mistakes. So sometimes Alice will sometimes pay a bonus for high effort, and sometimes will pay a bonus for low effort, but not for high effort. If she's a payoff maximizer, she'll pretend to be a tit for tatter so that Bob will put in high effort, and then she's going to double cross him at least in the last period. Okay. I think the double cross is with the 2 crosses is one of the original things of this presentation, by the way. Okay. Okay, so then we have this proposition that even if Alice is trembles, or she's a payoff maximizer, if delta, Bob's belief that Alice is a tit for tatter is sufficiently high, there exists an equilibrium where Bob exerts high effort in the first period. Right, so again, how much time do I have?
About 20 minutes.
20 minutes, okay, that should work well. Okay, any questions at this point? Okay. 3 key points. Bob has a strong incentives to try at high effort in the hope of a bonus. And in fact, most Bobs did in the experiment. By the end of the game, or partway through, Bob can update his beliefs on whether Alice will reward his effort with the bonus. And of course, whether he gets a reward depends on Alice. We need a little flat table over here. Okay. This lectern is sloped. But what we're really interested now is how the experience, how your experience, or Bob's, how the experience of employers and employees, particularly employees, will depend on their experience, right? As in our 2020 paper, you know, did they get a lot of bonuses or did they get few? Was there Alice, Bob's a particular Bob's Alice, a tit for tatter, even to some extent. So we can actually calculate in the experience, and theoretically, of course, we can calculate the average payoff to Bob when he exerts high effort, which we denote by W bar H, and when he exerts low effort, W bar L. So we deem him a type effort pays if his rewards, if his average reward when he puts in high effort is greater than his average reward when he puts in low effort. And similarly, he's an effort does not pay if the converse holds. So we can categorize Bob's into these various types, just as we did on our 2020 paper. And again, as well, let's see, remember that Cartwright-Wooders 2020 obtains the result that effort pays are fairly accurate in estimating the effort of others, while non-pays, right, significantly underestimate the effort of others. So we can ask if those results continue to hold. And as I sort of alluded to also, and as you may predict, because otherwise I might not have a paper, they do. Okay. Questions with the theory? Okay. Subjects were randomly allocated to one of two roles, workers or employer. A worker and employer were then matched to form a firm that interacted over 20 periods. The worker and each period we played the labor market trust game described in the preceding section. And workers had exogenous differences in own experience, right? What happened to them was dependent much on Alice and of course on what they themselves did.
Myrna, maybe one question before you switch to part 2. In your game between Bob and Alice, they play simultaneously or they play sequentially? The game between Bob and Alice, right. Is it a sequential game or is it at each round? It is a sequential game?
Right. First, okay. Bob decides whether to put in a bonus or to put in effort, and then Alice decides whether he's going to give a reward or she's going to give a reward, right?
Okay. Thanks.
Okay. So, and after they do that, then in part 2, this is in some sense where the rubber starts to meet the road, right? How does your experience affect you? Each subject is shown one by one the bonuses of 10 worker-employer pairs from the final rounds of the part 1 of the experiment, like the final 10. And again, inputs or the effort were not observable. You just saw what kind of bonuses they get. Okay. One thing I thought about with this is way back in 1984, I published a paper which was very derivative of prior working papers of mine. It was an extension to a compact metric space, which is kind of standard mathematics. It was published in Econometrica. And then my co-author, who is kind of a late comer to this, was invited to many conferences. It was amazing. Okay. Nobody saw the effort, right? Nobody realized, I suppose, that I had done a lot of work and written 3 working papers on TU games. And then, in fact, I published one of them on NTU games, which was very difficult in the Journal of Mathematical Economics. And then I did this extension to a compact metric space, and we did it in 3 weekends. Lead article in Econometrica. My co-author was invited to all sorts of conferences. Maybe they thought people thought that he would bring me, but he took his girlfriend. Okay. Maybe they thought I was his girlfriend, right? Yes. Okay. So we wanted, of course, to incentivize people to be accurate. So a subject received 50 pence for every estimate within 2 of the actual value. And we view the CV as more reflective, or at least as reflective of the opportunities available to the worker as dictated by the employer rather than the preferences of the workers. We did 8 sessions, 176 subjects split into 88 worker-employer pairs. Neutral language as is standard, no reference to worker-employer, just player A and player B. Both workers and employers did part 2. And what are our hypotheses from the theory? Okay, what are our, yes, that Bobs will exert high effort in at least 1 period. Everybody's going to try putting in high effort. Yes, another question here. It's only the people online who have to send you emails, chats, got it.
One question, so basically, can you tell what was the background of the subject? So have they studied economics, and if so, at what level?
Yes, I can tell you that they were students from Kent University in the United Kingdom. Generally, they hadn't studied game theory. There were some students who played some subjects, however, who chose minimal effort every period. They had probably studied game theory, right? The ones who did the worst had probably studied game theory. Okay. That's why I said earlier, you know, you teach it, and I tell my students, but don't accept the game theoretic solutions are not prescriptions about how to play games. Okay. And yeah, but most Bobs did exert high effort in at least 1 period, and there will be heterogeneity in employers, right? And indeed there was, allowing us to distinguish workers for whom effort paid and workers for whom it did not. Workers who have type EP, effort pays, will be relatively more accurate in estimating the average effort of other workers based on their CV. You know, and workers of type NP will have a tendency to underestimate the average effort of other workers. I want to interject here. Right. That in our 2020 paper, we have a theorem that shows that this is consistent with the theory, right? For the experimental parameters that we use. And Edward has done 100,000 simulations, varying the endpoints and so on, that, from which effort can be chosen. 100,000 simulations, and every simulation gives the same result, right? In the simulations. There should be a theorem. We can't prove the theorem. Yes. The theoretical of this? Boy, you know, I've been asked that question before, and it's really hard. Right. I think that's the answer. We don't have, I don't have at this point. Maybe I will after this seminar is over, because sometimes, you know, I get nervous when I give seminars, right? The highlight for me of the seminar is when it's over, sorry. So that's, although I'm enjoying this one actually quite a bit. Okay, maybe that's because I really find this subject very interesting. Okay, yeah. the intuition is really, it's hard to see. And I think if we could see better the intuition, we might be able to prove a general theory, but we don't. You know, it's a real open question to a probability theorist. And again, we get, as I said, the results of people who are NPs underestimate. So now I'm going to just talk about some graphs. Okay. So this shows, whoops, I got to put it up a little bit more. This first graph shows that the top is a cumulative high effort. Everybody tries the, well, figure 1A, proportion and cumulative proportion of worker-employer pairs where workers have chosen high effort and employer has given a bonus at least once. So at least once it worked. So it means that they tried, right? Bob tried at least once, most Bobs did. And the proportion of workers exerting, and this one is the proportion of workers exerting high and low effort who receive a bonus. You see, working pays, right? This is the ones who put in low effort, okay, who received a bonus, and this is putting in high effort and who received a bonus, right? You see, fortunately for most people, they don't follow game theoretic solutions, as I've indicated before. How are we doing on time?
About 5 minutes, maybe a bit more than that.
5?
5 or
okay.
Depends on the question after.
Okay. So we calculated the average payoff, as I said before, and we classified workers according to whether they were type EP or NP. Okay. And remember, those were EP if they did better when they put in effort, and they were NP if they did worse or better, were best when they didn't put in effort, right? We had 53 of type EP and 23 of type MP. And as I point out here, 5 always chose high effort, right? We designated those as EP. And 10 always chose low effort, designated as NP. Those are the ones who took game theory, I'm sure. Okay. The next figure plots the average effort of players of both types. You see, we get quite a bit of a difference here. Right, the workers of NP, the effort didn't pay, put in low effort, and the workers for whom effort paid put in high effort to begin with, and then they were decreasing. They were trying to kind of see how much they could get, you know, trying it out. Can they get a bigger proportion? Alice gave a bonus when you the worker put in 32. Will she give a bonus when you put in 30? Well, if she did, well, then maybe you should only try 28 next time, and so on. So that's kind of intuitive. That is intuitive, okay. And we can see that to a certain extent, the effort doesn't pay people were trying, right? They were trying on average. Okay, the average estimate and error of workers depending on the number of bonuses on the CV. I want to focus in particular on this. You know, for low, yeah. This graph shows that really it's in this area of maybe 2 to 7 or so, that there's really a divergence, right? That the errors that the people make in estimating the effort of other people are, you know, in this range, the effort pays people are quite exact. In this range, the effort pays people kind of, or the effort doesn't pay, really sort of estimate high effort for other people, right? Estimate high effort, right? I mean, you know, maybe they're just kind of blown away by somebody getting so many bonuses. Okay, so what are the conclusions of all of this? Right. So besides creating discrimination in the lab, we also find, though, that effort doesn't pay people, in some sense, discriminate against everybody, right? They underestimate the effort of everybody. So is this discrimination? Well, what we think about it is something like this, okay, or how we interpret the results. You know, historically, women were really less capable than men when it comes to doing things like you know, lifting, shooting a bear with your arrow and then carrying it home, right? Women do not have generally the same upper body strength as men, and that historically, right, in ancient times was probably important. Okay, and I think that's consistent with evolutionary theory also. But then what we have is that we have a history of, say, the work of women that could lead to a current situation where the work of women is undervalued, right? Their male co-authors get invited to conferences. Female co-authors get invited to dinners. Okay. If somebody invites, if a man, at least in my experience, sorry, if a man invites you to dinner, doesn't mean he's going to, and likes you, it doesn't mean he's going to like your paper. You know, I think that there may be very little correlation. Okay. So then when you know, then I think that when you write a paper, it may be that the woman writes a paper, you know, and it gets published, then that may be more attributed to luck, right? Or I don't know what, but anyway, and thus the luck matters people. The luck matters people. The people for whom you know, they had good backgrounds, went to good schools, and so on, right? May underestimate or undervalue their work. Yes, you had a question. Here. Yeah, start at the beginning.
So if women's contribution is discounted, it should affect the strategy of co-author choice. So for instance, strong women should not choose to work with men. Isn't it the case?
Yeah. So like, I think what you're saying is that if people know this, then there's an incentive to hire, say, women, right? Yeah. And I think what we're seeing now is that, yeah, people are more open to hiring women than they were. In fact, right now there's a premium on being a woman. Apparently, you're more likely now, if you're a woman, to be accepted in the Econometric Society as a fellow than if you're a man. Sorry, there's discrimination against white men. Too bad. I don't know. Okay, so yeah, and I guess one thing, you know, if you have a lifetime of experiences where you're lucky, right? It surely has an impact, right? This says in 10 choices, in 10 decision problems, your ability to estimate the efforts of other people is affected by your experience in those problems, right? Okay, so I think we have time for a question or two.
Yeah, sure. Unless you want to continue a bit, we still have a few minutes. I don't
Pardon?
know. We can stop here if you like and ask questions.
Yes.
Yeah,
that'd be
okay. No question from the chat, but maybe from the audience. I don't know. Yeah.
Yes.
I'd like to ask about your first figure that you showed, also the payoffs to employers, and you had there some employers, I think around 10%, who paid also for low effort, and I would be curious that how did those employers perform in terms of their total payments or the total surplus?
Ah, okay. So how did the employers estimate? Okay. The employers, if I remember correctly, we're kind of consistent. We hadn't with the employees, right? That wasn't something, in fact, we did that, but I don't recall us putting in the paper. After this conference and the PET conference, of course, I'm going to go to work with Edwards more, and we'll make sure that that's there. Okay, thank you.
Few questions. Two are about experimental designs. So why do you have a range of efforts that goes beyond the minimal effort that draws a reward?
Oh.
I'm just wondering whether you're testing for something other than the main issues you presented.
Oh, okay. I think if we stopped at, like, I think for the experiments for 28, at 28, right, which is if they put in more effort than 20, at 28, it's worthwhile to give the bonus. I think that you know, people tend not to choose endpoints. I think it would bias the experiment. Okay, people, and you know, they don't choose a lot of endpoints. They kind of hedge, right? As you know, if you have, say, 5 things in the 5 boxes, right, and somebody has to choose which one they want, think the prize is under, they typically choose the middle things too much.
Makes sense.
Okay, that's another question. Well, I hadn't thought about that one.
Okay. I have another one. Have you thought about trying to see how, so your talk reminds me, the setting reminds me of the theory of efficiency wages. And usually when people use game theory to look at efficiency wages, they look at the usual repeated game, but it's open-ended, or it's infinite horizon if you wish. Have you thought about lengthening the horizon or making it indefinite or infinite, but in the sense of experimental economics, meaning that at each stage there's a finite probability of termination?
Right, right. We've thought about that some, actually, and I think we may do that in future work. I mean, we're also improving you know, we need fewer choices. That's one aspect, right? You know, fewer choices would mean that there are clearer results. And of course, as you point out, if we did that, we're much less likely to get these end game effects, right? There's some papers that have done that, right? And that's what happens.
Thank you. I have some more questions, but I'll let some others ask. Come back to me later.
Okay. Any other questions?
Okay, so no, well, I think Robbie has one more question.
Then I have one more question. I was just wondering what the role of having characteristics be unobservable in the experiment is, and whether you have thought about extensions where you would make everything observable to the two parties.
That's a very, very interesting question. We have thought about that. Here, you see, observable characteristics don't matter, right? You don't observe the characteristics of other people. And actually, it's quite difficult to put in observable characteristics, but we're doing this. And I did it with my small class, a small class, and we used Turkers, Amazon Turkers. And we had, I think it was 8 types of people, okay, observable characteristics. And the subjects would see avatars. We didn't tell them this was the avatar of the person who did the experiment. We just put the avatar along with the bonus record, right? And what we found, I think, is very interesting. Okay, we find that white men were deemed to have put in low effort, even if they got high rewards. White men, they put in, you know, they get a bonus of 6 or 5, and they put in low effort. That was the worst, right? The kind of the bottom, right? The people who were deemed to put in high effort, the highest effort people, if they got a lot of rewards, were the Black women, right? If they got a lot of rewards, then they must have put in high effort, right? They must have put in high effort. Whereas white men, if they got high rewards, didn't have to put in much effort. Okay, this experiment was done with Turkers. I think that a close associate of mine, actually my son, okay, says that this is discrimination against white men. Okay. I don't know. Anyway, that was only a small classroom experiment. We don't have any significant results, but wait for it. Okay. Okay.
Okay. That's one question here.
So one of the
Yes.
things, you know, this is all very neutral, right? So the framing was without the avatar, it's all very neutral. Yes.
Yes. So two questions. So first, do you find surprising that I mean the inference is influenced by one's own experience? And second question, have you thought of modeling that as a psychological game in which your payoff depends on your beliefs, and the low effort agents want to sort of minimize the difference between high effort and low effort because their payoff depends on their own perceived laziness?
Okay. So do I find it surprising, our results? Right, first thing. I think one of the things is after you get results, nobody finds them surprising. Okay, right. But yeah, I think it is surprising that just 10 experiences, right? And it changes, it separates the beliefs of various people. It separates their behavior. It separates how they interact with others. And with regard to psychological games, right? We haven't related this to the psychological game theory literature. I don't know what the relationship would be, right? Maybe we could talk about it after, and you could suggest some things that we should have a look at. Well, I'd appreciate that. Thank you.
Okay, any other questions before we go to lunch? We still have a couple of minutes. Yes, no, yes. Question here.
My question is, for each of the agents, how can you tell what their perceived level of effort is? Because maybe on the scale, one person's level of effort, even though it's the same number on the scale you provide, in their perceived effort is different from some of the other agents.
Yeah. Their perceived effort from the viewpoint of Bob, who's putting in the effort. Okay. Well, in some ways we can't, right? I mean, so Bob, I mean, some Bobs just like to put in effort, right? I think there were 5 who just put in high effort all the time. Okay. Now, they may be, you're right, they may be happy doing that, right? Or because that's their sort of moral code, right? And the ones who put in low effort all the time may be extremely risk averse, right? I mean, so we can't tell, but we can tell about the averages over this sort of relatively large number. That's all we can do. You know, it's a problem with experiments in general, okay? People have different utilities for money, right? People, you know, like in the dictator game, right? People don't play the game theoretic solution. In general, people won't set, and on average, they want at least 25% of a dollar, right? And other people will take lower amounts. Other people will not accept 25%. Some people will only accept 50%, right? So we can't know that. But of course, all we can look at is the averages. Okay, but thank you.
One last question.
Okay.
Last one.
Thank you. A small comment and a small question. In principle, it could be possible to make a survey before the experiment, just to take into account unobservables like attitudes, beliefs, or something like this. And my question is, did I understand correctly that the agents, the participants of the experiment, didn't have information about others' choices? So it was like,
Right. They didn't have information about others' choices, so their decisions were entirely independent, right? They
Yeah.
didn't know what other people were doing. And did I interpret the first part, your first question correctly? Did you want me to write a survey? I think it'd be a good idea. I think you should do it. Right.
but exactly before the experiment, just to gain some information on the participants.
Oh, I see, to survey the participants. Oh, I think we did look at demographic data, but there was not anything interesting, right?
I mean, not demographic, but their beliefs, attitudes, and this kind of stuff, like psychological stuff.
Right, sort of a psychological survey of participants. No, we didn't do that. We didn't think of doing that. It might be interesting to do that. I'm not sure. You know that I probably share the biases of my profession, okay? And that means that I'm not really keen on kind of, survey questions like, right? Okay, although maybe some of these things like, what do you call it? Where you see these pictures and they flash by you and you have to sort of say, okay, sort of scientific attitudes towards women and men. What do they call? They're out of Harvard. Implicit bias or implicit association, right? Maybe we could do an implicit association, right? Have the subjects do implicit association testing to see what we can see. But one of the problems with those, of course, is that the implicit bias testing, right? Implicit bias association testing does not correlate often so well with behavior, right? So people may be exhibit a strong preference, right? In these tests, okay? And then it may not affect their behavior, it may not be indicative of how they will actually behave, right? Right. There is a lot more work we could do on this, right? And you could write a survey. That would be great. Okay.
Okay.
Thank you.
Myrna, thank you very much for this presentation.